Hi dear students, welcome to online classes. I am Virpoksh BP. In today's class, we are going to discuss about fifth physical property, that is electronegativity. What is electronegativity? The tendency to attract shared pair electrons by an atom in a covalent molecule is called electronegativity. Just I am taking covalent molecule. In covalent molecule, both atoms are covalently bonded. This is A atom and this is B atom. Both atoms are covalently bonded. What is the meaning of that? That means both atoms shared equal number of electrons. A atom shared 1 electron, B atom also shared 1 electrons. When both atoms share equal number of electrons, then covalent bond will form between A and B. In this molecule, the tendency to attract these shared pair electrons by an atom is called electronegativity. For suppose if A atom it attracts shared electrons towards itself, then A atom gets negative charge, B atom gets positive charge. In this case, we can say that the electronegativity of A is greater than B. That's why A atom is attracted shared pair electrons towards itself. That's why A atom got negative charge, B atom got positive charge. If suppose B atom it attracts shared pair electrons towards itself, then B atom gets negative charge, A atom gets positive charge. In this case, the electronegativity of A atom is less than B. That's why A atom get positive charge, B atom got negative charge. This is called electronegativity. What is the meaning of electronegativity? The tendency to attract shared pair electrons in a covalent molecule is called electronegativity. The tendency to attract, the tendency of an atom to attract shared pair electrons, shared pair of electrons towards itself in a covalent molecule, is called as electronegativity. And electronegativity has no unit. Electronegativity has no unit. And electronegativity is not a measurable quantity like ionization energy, electron gain enthalpy. It is not measurable quantity. It is not a measurable quantity. Why? Because the electronegativity values are not constant. It varies. It depends upon the element to which it is bounded or bonded. For example, A. When A is bonded with B, the A atom electronegativity is 3. Just rough numbers. These are not exact numbers. If same element A it is bonded with C atom, its electronegativity is 4. See, the electronegativity of an element is not constant. The electronegativity of A, it depends upon the element to which it is bonded. If it is bonded with B, its value is 3. If A is bonded with C, its electronegativity value is 4. So, it is not a measurable quantity. And mainly there are two scales to measure electronegativity. There are mainly two scales. One is Mulliken scale. The second one is Pauling scale. Pauling scale is most widely used scale. It is a most widely used scale. Widely used scale. According to Pauling scale, he has given some approximate electronegativity values for few elements. Now let us discuss lithium, sodium, potassium, rubidium, cesium, francium. Next, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Next, sodium, magnesium. Next, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. For these elements, they have given approximate electronegativities. They are not exact electronegativity values, just they are approximative electronegativities. For lithium 1, for beryllium 1.5, for boron 2.0, 2.0, next 2.5, 3.0, 3.5 and 4. Next for sodium 0.9, for potassium 0.8, for rubidium 0.8, for cesium 0.7, francium 0.7, for magnesium 1.2, next 1.5, 1.8, next 2.1, next 2.5, 3.0, next 2.8 and 2.5. These are the approximative electronegativity values. According to these values, the fluorine as first highest electronegativity element in the periodic table. Fluorine is first highest electronegativity element. Next, which is second highest electronegativity element? Oxygen. Next, nitrogen. Second one, oxygen. Second highest electronegativity element. Oxygen is second highest electronegativity element. Next, nitrogen. Nitrogen is the third highest electronegativity element in the periodic table. Okay. Now, see here noble gases. For noble gases, the electronegativity is 0 due to stable oxidation, due to stable electronic configuration. They have 0 electronegativity. Noble gas elements have 0 electronegativity. 0 electronegativity. Why? Because they have stable electronic configuration or they have octet configuration. They have octet configuration. That's why they have 0 electronegativities. The next point, group 17 elements are halogens. Halogens have high electronegativities. Why halogens have more electronegativities? Because of two reasons. One is halogens are smaller in size compared to other group elements, because size decreases along a period. From left to right, size decreases. So the 17th group elements are smaller in size. Due to smaller in size, there is a more effective nuclear charge. This is the first reason. The second reason is halogens have more tendency to attract electrons to attain stable electronic configuration. This is second reason. The first reason is they are smaller in size. And more effective nuclear charge. The second reason is they have more tendency to attract attract electrons to attain stable electronic configuration. Stable electronic configuration. Electronic configuration. Right, because the general electronic configuration is NH2NP5. Right, this is the general valence shell electronic configuration. By gaining one electron, the electronic configuration becomes stable. That's why they have more tendency to attract electrons. This is the second reason. Okay, that's why the group 17 elements or halogens have high electronegativities. The next concept is trends of electronegativity in periodic table. In a period, electronegativity increases from left to right. Electronegativity increases from left to right. From left to right. Why electronegativity increases from left to right? Because atomic radius decreases from left to right and effective nuclear charge increases. The reason is atomic radius decreases from left to right and effective nuclear charge increases. Effective nuclear charge increases. That's why electronegativity increases from left to right. Here electronegativity is directly proportional to the effective nuclear charge. Electronegativity is inversely proportional to the atomic radius. For example, see, this is a small atom and this is a large atom. Both atoms share equal number of electrons and form covalent bond. This is A atom and this is B atom. A atom shared one electron, B atom also shared one electrons. Here this is nucleus and this is nucleus. In A atom, the shared electrons are more close to the nucleus. In B atom, the shared electrons are more away from nucleus. That means there is a large distance between shared electrons and nucleus in B atom. In A atom, there is a small distance between nucleus and the shared electrons. Because of small distance, there is a strong force of attraction between nucleus and shared pair electrons. That's why the small atom have more electronegativity than large atom. Okay, here A is small atom, it attracts the shared pair electron towards itself and it gets negative charge, B gets positive charge. That's why as atomic radius decreases, electronegativity increases. As atomic radius increases, electronegativity decreases. Small sized atoms have more electronegativities than large atoms. Next, B. In a group, electronegativity decreases from top to bottom. Electronegativity decreases from top to bottom. Why electronegativity decreases from top to bottom? Because atomic radius increases from top to bottom. The reason is atomic radius increases. Atomic radius increases and effective nuclear charge decreases. Effective nuclear charge decreases. That's why the electronegativity decreases from top to bottom. As the size increases, electronegativity decreases. Why? Because large distance between nucleus and shared pair electrons. This is the trends of electronegativity in periodic table. Next, let us discuss about applications. Applications of electronegativity. The first one is metallic and non-metallic character. Metallic and non-metallic character. Non-metallic character. We know that metals have more tendency to lose electrons. That's why metals have less electronegativities. That's why metals are inversely proportional to electronegativity. Metals have more tendency to lose electrons. Why they have more tendency to lose electrons? Because of larger in size. Due to larger in size, metals have more tendency to lose electrons, and metals have low electronegativities. That's why the electronegativity is inversely proportional to metallic character. As the electronegativity increases, metallic character decreases. Next, non-metals. Non-metals have more tendency to attract electrons. Non-metals have more tendency to attract electrons. And have more electronegativities, have high electronegativities. That's why the electronegativity is directly proportional to non-metallic character. Okay. As electronegativity increases, non-metallic character increases. As electronegativity decreases, non-metallic character decreases. So here electronegativity is inversely proportional to metallic character, and it is directly proportional to the metallic character. Now let us know the relation between metallic character and electronegativity in periodic table. From left to right, electronegativity increases, right? Electronegativity increases. As electronegativity increases, what about metallic character? Both are inversely proportional, right? As electronegativity increases, metallic character decreases. From left to right. From top to bottom, electronegativity decreases. Right? As electronegativity decreases, what about metallic character? Metallic character increases. Next, now come to non-metallic character. Electronegativity is directly proportional to non-metallic character. From left to right, electronegativity increases. Then what about non-metallic character? Non-metallic character increases. As electronegativity increases, non-metallic character increases. From top to bottom, as electronegativity decreases, non-metallic character decreases. This is the trends of metallic and non-metallic character in the periodic table. The next concept is periodic trends in chemical properties. The first one, valence or oxidation state. What is oxidation state? The charge on atom in a given species is called oxidation state. The charge on an atom in a given species is called oxidation states or valence. Valence or oxidation states indicates number of electrons lost or gained or shared with other atoms in the formation of compounds. It indicates number of electrons lost or gained or shared with other atoms in the formation of compounds. And oxidation states may be positive, negative or zero, or it may be fractions. Oxidation states may be positive or may be negative or zero, or it may be fractions. In case of representative elements, the valence or oxidation states are equal to either number of valence electrons or 8 minus number of valence electrons. In case of representative elements, valence of an element either equal to number of valence electrons or 8 minus number of valence electrons. Okay. In case of representative elements, the valence of an element is either equal to number of valence electrons or 8 minus number of valence electrons. This is the tabular column. In tabular column, these are group numbers and these are number of valence electrons and these are valence. Now let us see. In group 1 elements, the number of valence electrons are 1. In group 2 elements, the number of valence electrons are 2. In group 13, the number of valence electrons are 3. In group 14, the number of valence electrons are 4. In group 15, number of valence electrons are 5. In group 16, the number of valence electrons are 6. In group 17, the number of valence electrons are 7. In group 18, the number of valence electrons are 8. The number of valence electrons, that means number of electrons present in outermost shell. Now, for group 1 elements, the valence is 1. For group 2 elements, the valence is 2. For group 13 elements, the valence is 3. Group 14, the valence is 4. For group 15 elements, the valence is 3 and 5. For group 16 elements, the valence is 2 and 6. For group 17 elements, the valence is 1, 7. For groups 18 elements, the valence is 0 and 8. Because the valence of an element is equal to number of valence electrons or 8 minus number of valence electrons. Up to group 14 elements, the valence is equal to number of valence electrons. From group 15 to group 18 elements, the valence is equal to 8 minus number of valence electrons. See here, 8 minus number of valence electrons. See here, 8 minus 5, 3. Here 8 minus 6, 2. So, the valences for 15th group elements are 3 and 5. For 16th group, 2 and 6. For 17th group, 1 and 7. 0 and 8 for group 18 elements. Now, group 1 elements have one valency, that indicates group elements maximum they can donate one electron and they can share one electron. Maximum they can share one electron. Next, for group 2 elements, the valence is 2. That indicates group 2 elements maximum they can donate 2 electrons and maximum they can share 2 electrons. Next, group 13 elements. For group 13 elements, the valence is 3. That indicates group 13 elements maximum they can donate 3 electrons and maximum they can share 3 electrons. Next, group 14 elements, the valence is 4. That means maximum they can donate 4 electrons and maximum they can share 4 electrons. For group 15 elements, the valence is 3 and 5. Here see, for group 15 elements, maximum they can donate 3 electrons and maximum they can gain 3 electrons and maximum they can share 5 electrons. See here, group 16 elements have valency 2, 6. That means maximum they can donate 2 electrons, maximum they can gain 2 electrons and maximum they can share 6 electrons. Group 17 elements have more electronegativities. They have more tendency to gain electrons. That's why they will never donate electrons. That's why for group 17 elements the valence is 1 and 7. That means group 17 elements maximum they can gain 1 electron and maximum they can share 7 electrons with other atoms. And group 18 elements, the valence is 0 and 8. That means group 18 elements will not participate in losing or gaining electrons. And maximum how many electrons group 18 elements can share? Maximum it can share 8 electrons. This is the valency of an element in case of representative elements. Now let us discuss some examples. OF2 molecule. OF2 molecule. In OF2 molecule, oxygen is bonded with 2 fluorines. Oxygen is bonded with 2 fluorines. Here in this molecule, oxygen shared 2 electrons with 2 fluorine atoms, right? Oxygen it shared 2 electrons with 2 fluorine atoms and each fluorine atom shared 1 electron with oxygen. Each fluorine atoms shared 1 electron with oxygen. Now between oxygen and fluorine, which has more electronegativity? Fluorine is more electronegativity, right? The electronegativity of fluorine is greater than oxygen. That's why the fluorine atom it attracts shared pair electrons towards itself. The fluorine atom it attracts the shared pair electrons towards itself and it gets -1 charge. In this case also fluorine it attracts shared pair electron towards itself and it gets -1 charge. In this case oxygen loses 2 electrons. That's why the +2 charge. In this molecule, what is the oxidation state of oxygen? +2. What is the oxidation state of fluorine? -1. Next. Oxygen Na2 molecule. Here also oxygen is combined with 2 sodium atoms. 2 sodium atoms. Here oxygen shared 2 electrons with 2 sodium atoms. Oxygen shared 2 electrons with 2 sodium atoms and each sodium atom shared 1 electron with oxygen. In this molecule, which has more electronegativity, oxygen or sodium? The electronegativity of oxygen is greater than sodium, right? Oxygen has more electronegative than sodium. That's why oxygen it attracts shared pair electrons towards itself. It attracts shared pair electrons towards itself. So oxygen it gains 2 electrons from 2 sodium atoms. That's why it get minus 2 charge. And here each sodium it donates 1 electrons. That's why each sodium gets plus 1 oxidation state. In this molecule, what is the oxidation state of oxygen? Minus 2. In this molecule, what is the oxidation state of oxygen? Plus 2. Plus 2, that indicates oxygen is donated 2 electrons to 2 fluorine atoms. In this case, the oxidation state is minus 2. What it indicates? That indicates oxygen is gained 2 electrons from 2 sodium atoms. Why it gained 2 electrons? Because the electronegativity of oxygen is greater than sodium. That's why oxygen it attracted shared pair electrons towards itself. Valence of an element is useful in predicting formula of the compound. Valence of an element is useful in writing formula of the compound. Now I will consider 2 pairs. One is silicon bromine. This is first pair. The second pair is aluminum and sulfur. Now you write formula of this pair and formula of second pair. To write formula of this pair, first you write valences. Silicon it belongs to which group? Silicon it comes in carbon family, right? The carbon family present in which group? 14th group. Bromine it belongs to which group? Fluorine, chlorine, bromine, 17th group. Now tell me, what is the valency of 14th group elements? What is the valency of 14th group elements? 4. What is the valency of 17th group elements? 1. Right? 1. Now you write the silicon valency is 4, bromine valency is 1. You just do cross multiplication. Silicon tetrabromide. This is the formula of this pair. Next, for this pair, aluminum belongs to which group? Boron, aluminum. Boron, it belongs to which group? Boron family. Aluminum, it comes in boron family, right? Boron, it belongs to 13th group. Next, sulfur. It belongs to which group? It belongs to 16th group. Next, what is the valency of 13th group elements? What is the valency? 3. Next, what is the valency of sulfur? Sulfur is belongs to 16th group. 16th group valency is 2. Now, aluminum valency is 3, sulfur valency is 2. Just you do cross multiplication, Al to S3. This is the formula of second pair. In this way, we can predict formula of compound by using valency of an element. We will continue in next class. Thank you.